So I want to take a look at electron configurations. We're going to do it a couple of different ways. First thing is, let's look at calcium. So to figure out how many electrons for calcium, I look at its atomic number. So calcium's atomic number 20, which means it has 20 electrons. And so we're going to do it both the longhand and the shorthand. So the longhand, I write down each individual electron, which energy level it's at, and if it's sp,d, f orbital, etc. So to start off, the first two go into the S, so 1s2, 2s2, and then these are the actual amount of electrons. Always keep track. And then 2p6, 3s2, 3p6. So far I've counted up. I've got 2, 4, 10, 12, 18. Now, the next two electrons go into the 4s orbital. So 4s2. So kind of be aware of that. We drew that diagram in class. It goes 3p and then 4s and then back to the 3d. So 4s orbital. This happens to be a little bit lower in energy. And then these right here are the valence electrons. So these are the valence electrons. To do the shorthand method for calcium, again, you can't really see it in the video. I use the noble gas before it, which is argon. Argon takes up 18 electrons, so it takes up these 18. Write down what's left over. It's going to be 4s2. So basically, calcium is a period 4. I go 4s1. It's in group number 2, so it's 4s2 electrons. So again, be able to do both methods. Let's look at arsenic. Arsenic's kind of long. Arsenic has 33 electrons. So it's over here. It has p electrons being filled. Let me go ahead and do the longhand method. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. After 4s2 comes the d's. So 3d10 and then 4p3. So we start with arsenic. It's 4p3. To do the shorthand method, I write the nearest noble gas in parentheses, which is argon. That takes a couple 18 electrons. A couple of things, when you're filling this out, I kind of did this in class. I go 4s2, so it takes up these. These in the middle are d electrons, the transition metals. It's always one less than the period. So it's period 4, so fill 3d. Period 5, fill 4d, etc. So the next 10 go in 3d10, and then 4p3. A couple of things, again, this could be a little bit tricky. The valence electrons are the S2s and the 4 and the P3. So the valence electrons are always in the highest end. Let's do the last one quickly. So this is 10. This is 50 electrons. For 10, that's to do the shorthand method. So 10 is going to be a period 5. So the noble gas before it is actually, let's see, what's 10 going to be? It's going to be krypton. That takes care of 36 electrons. I go to period 5. The next two electrons go in 5s2. And then 4d10. So again, I got to fill out the 4ds. And then back to the 5p's. And 10 would be 5p2. Let's do one more quickly. We got some time. Let's look at barium. So barium, if you look at your periodic table, is actually group number 2. It's on period 6. So the noble gas before it now is going to be xenon. Barium has 56 electrons. Xenon takes care of 54. And then it's period 6. So 6s, 6s2. So it's group 2. So the last two electrons go in 6s2.